folks, MBS here. Today I'll be covering cooling systems part 1 and part 2. Part 1 will just be talking about basic operation, how the system works. In this vehicle it's a closed loop system, and I'll explain to you exactly what that is and a couple of other systems that exist in the automotive industry. So let's get the camera positioned and have a look how this goes. Okay, before we start looking at this, I'll just put on the background music. Beautiful birds tweeting away and pigeons purring and whatever. So it makes good background music for the vid. Okay, so here we have water in the system. You start the engine up. No water can flow into the radiator. Okay, it's blocked off by the thermostat, which is right here. One of the primary jobs of the thermostat is to warm the engine up as quickly as possible, and this is done by not allowing any water to come through the system, and the water just regurgitates within itself inside the engine block, and that heats the water up fairly quickly from the heat created by combustion. The reason we want the engine warm is the engine has less wear, it responds better, the fuel vaporizes better, so this is what one of the primary functions of the thermostat is to achieve all this. And like I said, it's achieved by not allowing any water to flow through the system, and the water just regurgitates upon itself. Once the engine warms up and it's up to the operating temperature that the manufacturer desires, in this vehicle it's 82 degrees, what starts to happen is the thermostat will start to open. And its second function is to keep the temperature at 82 degrees. So water starts to flow through to the radiator a little bit at a time. It just starts to crack open and allows water to come through to the radiator, which cools it back down and puts it back through the system. So as the water gets hotter and hotter in the engine, thermostat opens wider and wider and allows more flow, more cooling. Okay. So that's the simple operation of the thermostat. Once it gets to the radiator, obviously it's hot in here. It's at least 82 degrees. It could be a degree higher, it could be a degree lower, depending how well the thermostat's working. So it comes in hot here, but it comes out cold out the bottom. Well, when I say cold, it's not cold. There's still warmth in it, but it is substantially cooler than what it is when it comes into the top. Alright, now the radiator consists, well, basically it's a heat interchange unit. That's what I call it in the trade. It exchanges heat with the outside air. Alright, you've got a fan turning also, which is drawing air through the unit, and most cars will have a shroud built around the radiator to make sure that the fan isn't flowing false air. What I mean by that is it's taking air that's already inside the engine bay and drawing it in front of the fan and then pulling it through. That's not drawing air through the radiator, which is what we want. So yeah, this engine's actually missing the shroud, but it gives you a good view of down into the engine bay here. So yeah, we've got hot water that comes in here. The water flows down these very thin tubes down the radiator. Now there's a 2-core or a 3-core, there's even possibly 4-core radiators, heavy duty radiators. They become very wide. The more capacity the radiator can handle, the more efficient the cooling. So like I said, water comes in, it goes down these thin tubes. Now in between each tube we have very thin tin material or copper, whatever they make it out of on the day, and that material is what takes the heat away from the water. It exchanges the heat, the air comes through, keeps these little coils cool, which then takes the heat away from the tubes where the hot water is. Thereby, by the time the water gets down to the bottom of the radiator, it is cooled by at least around about 30 degrees or more. So the radiator is very efficient at what it does. As long as it's got air moving through it, it's got air being pulled through the radiator by the fan, everything is pretty sweet and it'll work exactly as it is designed. when these cores get rotten and there's no material, when I say cores, I mean the zigzag material that's in between each core. When that gets rotten and they fall out like this one is, then your cooling effect will be lost. So if you haven't got a high capacity radiator and it's just stock standard, if you lose about 20 or 30% of that material in between the cores, you'll probably find that the car may start to get a little bit hot in traffic, because it won't be able to cool it down until you're out on the open road where air is passing through the radiator and assisting that cooling. Now I've got a high capacity radiator in this one, so even though I've lost probably about 40% of my cores, I still get cooling, and I do sometimes get a little bit hot when it's in heavy traffic, but where I live there isn't much heavy traffic anyway. So the system still works, so I'm happy with that, and the vehicle's going to be retired shortly, so we're not too worried about the radiator in this one. Okay, as part of the radiator is the radiator cap, and it has a safety feature built into it that when you put it on, you give it one click. That's its loose fitting, and if you take it back to this click, this is where you could relieve the pressure, or if you want to run no pressure in your system for whatever reason, you may have a leak, so you keep the cap on loose. But there is danger with that, and I'll cover that in part 2 actually. So then you lock it by twisting it and pulling it down. Alright, the purpose of the radiator cap is to create pressure in the system. Alright, because while the water's flowing around, it's getting hot. Water expands when it gets hot. With that expansion, if you've got a solid system like this, you'll create pressure. Okay, if you were to block yourself totally, you would create a fair bit of pressure in the system. The pressure is restricted in this system to 13 psi as rated on the cap. There is, in the early days they had 7 psi, then mine is 13, then you have 15, and then there are 20 psi in the later model vehicles. Now that is designed very specifically to change the boiling point of the water. Like if water boils at 100 degrees Celsius atmospheric pressure, but at pressure, let's say 13 psi, the water won't boil till around about 125 plus degrees, because it'll be under pressure. You can check that it's under pressure by feeling the hose, and it'll be very tight when your engine's hot. Okay, so you'll know that your system is under pressure, and while it's under pressure you do not release it by the cap unless you absolutely have to, and I'll cover that again in part 2. Alright, so yeah, so while the engine's running, it's building up pressure, and when it gets to that pressure, it has to release it. Okay, so the pressure cap releases that pressure a little bit at a time to maintain it at 13 psi, and that excess water from the expansion comes along this hose and goes into a little reservoir bottle over here. Alright, there is a min mark and a max mark on that water bottle. So when the engine is cold and the water is contracted, the water will be sitting down near the mid mark. It shouldn't ever be below. Okay, so when you set this up, you make sure that it's just above min. Alright, so like I said, the water flows through, it gets hot, it expands, it creates pressure. The excess pressure is dumped into your reservoir, and that's relieved by letting some of the water out. Okay, so the water goes into your reservoir bottle, and it raises up and comes up to pretty close to the max mark when you're reaching operating temperature. Alright, so that keeps the water in the system. So what happens when we cool down? The water gets sucked back out of the bottle, back into the radiator. Inside the radiator cap there's a little valve in there that allows the water to come back. So as the water contracts in the system, in the engine, the radiator, it creates a partial vacuum, and it draws the water back out of the reservoir into the radiator. And that folks, is why it's called a closed system, because the water is allowed to expand, go into a bottle, retract and come back into the system, back into the radiator. Now there is another system earlier than this one, before the reservoir bottle was invented, and that was the open system, and that was nothing more than your overflow hose going straight down your radiator, straight out to the road. Okay, that was really early days, right from when the car was first invented, right up to about the 1970s, there or thereabouts, mid-65, something like that, is when this bottle came into effect. And most people always panic. They take off the radiator cap and the water was down an inch. They'd top it up. Next day it would be down an inch, forever chasing their tails thinking there's something wrong, but that was absolutely normal for those days, for the water level to sit down about an inch. Well, thank goodness they came up with this closed system, because then you never had to worry about that, because the bottle was always contained, the water was always contained in this bottle. So the owners of the vehicle will just come out and, yeah, there's water in the bottle, all sweet. And in part 2 I'll cover why that's a dangerous thing to think. Under pressure, every 1 psi of pressure in your system, the water's boiling point is raised by 1.8 degrees Celsius. So it's handy to know that, because later on I'll be talking about the diagnostics of the system in part 2, and we'll need to understand that the higher boiling point of the water, because in late model cars they run 95 degree thermostats, which is really close to 100 degrees Celsius of the boiling point of water at atmospheric pressure. And it sounds like fun, and it is fun when I start talking about that in the diagnostics, and it'll be I think that'll be an interesting video. Now what I haven't covered is the temperature gauges. In here you can see I've actually got 2. I don't know if you'd recognise the second one. That's an aftermarket gauge, a stepper motor gauge I've got fitted, and my stock standard temperature gauge is there. Totally different gauges. The stepper motor gauge, I know the actual degrees of the engine, so I can do a lot of diagnostic work with that, knowing the actual temperature. Plus the gauge has got a warning buzzer when the engine gets hot, and I've also got the whole gauge flashes when I reach 95 degrees. Alright, I can do that in this vehicle because the thermostat's 82, so I don't want the temperature to get close to boiling point of 100, so I have that early warning. Now in a lot of more modern cars, of course, not in this vehicle, but they have another gauge, probably sitting around about 3 or 4 inches down in the radiator, and that's to warn you when your water level gets low, which is absolutely fantastic if you've got that feature, because you won't know when the water level gets low on a trip or anything like that, or overnight. You're not going to check your system every day, so in between those times anything could happen, and that sensor in the radiator is a godsend. Very good idea that was, whoever came up with that one, and that gives you very early warning before you have no water in the system, and that will actually affect your temperature gauges, because your temperature gauges will not work unless liquid is passing by them with not much air. It's got to be pure liquid. Alright, once you start mixing air in with it, because the level gets too low, your temperature gauges will stop working. Okay, I'll cover that in part 2, the diagnostics, which should be an interesting video. Okay folks, well that was part 1. I hope I explained how the system works for you, and if you're left wondering about anything, look, leave me a comment, and I'll try and do an amendment later on, or an addition to the article as a separate video for you, or I'll just reply to you in the reply section on YouTube, and hope that'll help you out. Alright guys, I'll see you in part 2 in the not too distant future, and we'll talk about diagnostics of the system. Catch ya. Hope you learned something.